Dear students, welcome to the YouTube channel H2O Chemistry. In the last few videos, we have covered the first part of the lesson, periodic classification of elements. In the second part of the lesson, we have the topic called metallurgy. Okay, before I introduce this topic, I just want to ask few informations I want to share with you guys. We know that we use many metals in our day-to-day life. For example, we use gold, copper, iron, silver, nickel. Like this, there are many metals have been used. Now, my question to you is, where do you get these metals and how do you get these metals? To answer these questions, we want to study the process called metallurgy. Okay, what is metallurgy, my dear children? Metallurgy is very simple idea, my dear children. We know that the metals are found in the earth crust as ores or minerals, right? So by doing some processes, we extract metal from their ores. So this process is called metallurgy. So I can clearly say that the processes involved in the extraction of metals from their ores is called metallurgy. So it's a very clear idea, my dear children. So what do you call metallurgy? The processes involved in the extraction of metals from their ores is called metallurgy. Very simple idea. Or we use science and technology, right? So it is a science and technology. We use science and technology for what? To extract metals, right? To extract metals from their ores, right? From their ores. This process is also called as metallurgy. So this is what? Very simple idea. Now, what else you should know, my dear children? On what basis they extract these metals? Now, we know that the first basic idea is on what basis they extract this metal. The first one is they consider the physical and chemical properties of the metal. Physical and chemical properties of the metals. The second one, their structural arrangement of metallic atoms in the metallic crystal. So how they arranged in the crystal that they want to study, and based on that they do this metallurgy process. Last one depends upon their application. So these are the process or basis do the metallurgical process. Now let us go and learn about some important terminology used in the extraction processes. So we will go for the first idea, that is a terminology in metallurgy. So we are going to study some terms to understand the metallurgical process. Okay, now the first one is called mining. It's a very simple idea, right? So we extract ores or minerals from the earth crust. This process is called mining, right? So the process of extracting extracting the process of extracting ores from the earth crust is called mining. It's a very simple idea. You might have heard in the uh, geography lesson also. Mining is a very simple, easy way. We just take ores or minerals from the earth crust. This process is called mining. The second one is a very important one, that is called minerals. What are minerals? See, if you want to understand deeply, I can say easily it is, minerals are compounds of metals. Compounds of metals. For example, we know that a metal plus non-metal will form a compound. Let us take an example. Sodium plus oxygen will form a sodium oxide. So it is a compound. Sodium oxide is a compound because it's made up of two different elements. So minerals are nothing but a compounds of metals. It may be a single compound. It may be a single compound or mixture of compounds. So minerals are available as a single compounds or mixture of compounds. That's the reason I simply call it's a compound of metals. Compound of metals. Where it is present? It is present in the earth crust. So minerals are compounds of metals found in the nature associated with impurities. Normally, some example, if you see, we know that the calcium oxide, and it's a kind of mineral. Calcium carbonate, limestone, that is called marble. Similarly, we can call bauxite, Al2O3.2H2O. Clay is Al2O3 2SiO2.2H2O. So this is another mineral. So these are the minerals, my dear children. So where we get minerals? Minerals are the compounds of metals found in the nature associated with impurities like sand, stone, mud, etc. Now the next one is ores. What do you call ore? Okay, ore is a mineral actually. Ore, it is a mineral from which the metals can be extracted economically and easily in large amounts. That's what is very important, my dear children. So what is called mineral? Mineral is a compound of metal found in the nature with some impurities, whereas ore is a mineral. Again, it's a type of mineral from which metal can be extracted economically. Very important. Economically means the price or cost involved in the process of extracting metal is low, or we say profitably and easily. The process involved in the metallurgy is easy. In the large amounts means metal with a large quantity we can what? Easily extract. That is an idea, my dear children. It is called ore. For example, bauxite. It's an Al2O3.2H2O. It is an ore of aluminium. Ore of aluminium, which we can call aluminium, which we can call mineral too, because it's ore is a type of mineral. Remember, we can call mineral too. Got it? Now, there will be an important question asked to you like this. What is that? What is the difference between ores and minerals? So, you have to answer this in a easy manner. How will you answer? So, we will see what is the difference between minerals and ores. Minerals and ores. So, this is what you have to write, my dear children. What is a mineral? I told you it is a compound of metal. So compounds of metals or mixture of compounds, found in the earth, found in the earth. What is called ore? It is a mineral from which metals can be easily extracted. Here we have studied that metals, the minerals contains, it's an important point, low percentage of metal. This is what the idea, low percentage of metals, whereas ores contain high percentage of metals. So that is why we extract metal from ores. We don't extract from minerals, whereas ore is a type of mineral, remember. But the metals are extracted from ore alone because the metals are present. Metals have large amount of metals. The ores have large amount of metals. The minerals have less amount of metals. That's why we extract metal from ores, not from the minerals. Next one, the extraction of metals from all the minerals or is not profitable, but the extraction of metals from ore is profitable, because when you have a large amount of metals, when the process is easy to extract the metals, right, it is more profitable than the extraction of metal from minerals. Fourth one, what is an idea? Example. Let us take an example of clay. What is the formula of clay? Al2O3.2SiO2.2H2O. This is formula we call clay, right? Whereas example of ore is bauxite. Al2O3.2H2O. Now look at this. When you calculate the molecular mass of this clay and find out the mass percentage of aluminium, the aluminium percentage is less. Whereas here in bauxite, the mass percentage of aluminium is high. That means in the backside, the aluminium is present in large amount, whereas in clay the aluminum present in less amount. So extraction process is easy in the bauxite ore, whereas extraction process is difficult in clay. When you extract aluminium from clay, it's very difficult because it has a less amount of aluminium. That's what, my dear children. What is the one more idea? There is a one mark asked like this: is all minerals or ores? Is all minerals ore? Question asked like this. Okay, let us see a general one. A general one. From the same example, we can say clay. It is a mineral. Al2O3.2SiO2.2H2O. Bauxite. It is a ore. Al2O3.2H2O. These two are minerals, right? These two are minerals. Now, but in which the aluminium is extracted profitably? Only from the bauxite. Aluminium is extracted from bauxite alone. Here from clay we don't extract, right? So is all minerals ore? That's what my question. How do I want to answer? The both are called minerals, but the bauxite alone is called ore. Bauxite alone is called ore. Can I call clay is a ore? No. Clay is a ore. The answer is no, because we cannot extract what? Aluminium. So that is why clay is not a ore. Only bauxite is a ore. So I can say ores are minerals, but all minerals are not ores. All ores are minerals, because even a bauxite we call minerals, but clay we don't call ore, right? All the ores are minerals, but all ores are minerals, but all minerals are not ores. So this is a major idea, my dear children. You should know how to answer this. We have two minerals. One is clay, another one is bauxite. Only from bauxite we extract aluminium, not from the clay, because clay contain less percentage of aluminium, bauxite contain high percentage of aluminium. So clay is not a ore, it's just a mineral. But bauxite is a ore, but it's a type of mineral. So how do I explain? All ores are minerals. Even a bauxite is mineral, but all minerals are not ores. Here clay is not a ore, it's just a mineral. I hope you understand this 2 mark very clearly. Next we will go to the other term, that is gangue or matrix. Now tell me, what is meant by gangue? We know that when you extract ores from earth crust, it's associated with the impurities. So the impurities are called gangues, like sand. The impurities such as sand, stone, mud, etc. associated with the ore when the mining process done is called matrix or gangue. Matrix or gangue. So just a impurity, remember, rocky impurities we call, or simply impurities like sandstone or mud, like that. So the next one, the next term is called, what you're going to learn is called flux. What is my dear children? Flux. What do you call flux? Flux is just substance. It is a substance. Now generally we studied that when the metals plus non-metals react to form a compound, we know that metal and non-metal, it produces ionic compound. They have a generally high melting point. So in the extraction of metals, the melting point of ore is high. So when you supply large amount of energy to melt ores, we have to spend lot of money. So the cost is very high. So the process is not profitable. So what we do? We normally add a substance. The substance name is called flux. What is the role of this substance? The role of this substance is it reduces the melting point of mixture, melting point of the ore. In your book, the melting process is given as fusion temperature. The melting point is called fusion temperature. So when you add a flux into a ore, the high melting point of the ore is reduced to lower melting point. That means it reduces the fusion temperature of the mixture of the ore. That's the first idea, my dear children. So that it forms a I can say like what you can say, it is a impurity, right? You can easily fuse that, right? You can easily fuse means melting. Fuse here, which means melting. So reduces the fusion temperature of the ore. The second role of the flux is it removes impurities. It removes impurities by combining with a gang, by combining with the gang. So impurities nothing but gang. So this is what you have to understand. So what is the role of flux? It reduces the fusion temperature, that means melting point of the ore. So we can reduce lot of cost in the process. Am I right or not? Let's take case of important idea. Simply when a substance melts around 3000 degrees centigrade normally, ore normally melts at 3000 degrees centigrade. If we add one more substance, if it melts at 500 degree, right, the substance you add is called flux. So it reduces the fusion temperature or melting point. Now next is slag. What do you call? Slag. The slag is very simple. It is a molten impurity we call, or fusible product. The fusible product, or it is in molten state. What is called slag? I told you it removes impurities. Which removes impurities? Flux. Impurities are called gang. So the gang plus slag, the gang plus flux is called slag. So it is called fusible product. That means they are available in the liquid form, right? So molten state. So the gang and flux collectively called as slag. Am I right? Now in the flux area, I should teach one more concept, that is, if the ore is acid, acidic in nature, the flux should be basic, and vice versa. That means if the ore is basic, the flux should be acidic. For example, calcium oxide, it's a metal oxide which is basic in nature. So when you add a flux to this, it should be acidic. It should be a acidic one. Flux should be acidic one. So when you add a when the ore is acidic, you have to add a basic. So this is what idea you should know. This is one more important point you should remember in the flux area. So what is called slag? It's a fusible product formed by the mixing a gang with a flux is called slag. Is called a slag. The next process, a very important process, is called smelting process. Smelting process. Now, normally what we do in the metallurgy process is, right? So the ore, first of all, converted into fine powder, and then after impurities removed, so after removal of impurities, we do roasting process, or else we convert the ore into oxides. So our ore converted into fine powders, the fine powders are converted into oxides. The next process, from the oxides we get metals. From oxides we get metals. So it is a metallic oxides. From ore, the ore is converted, that's what important, converted into metallic oxides. From this we get metals. So this process is called smelting. What is called? Let us take an example. M is a metal, O is metal oxide. So if you get metal, this process is called smelting. We know that what do you call reduction? Removal of oxygen is called reduction. Removal of oxygen is called reduction. So here what actually happens is this oxygen is removed. Am I right? The oxygen is removed. So that metal we have got. Let us give an example. The zinc oxide plus, if you add a carbon monoxide, this carbon monoxide combines with this to form zinc plus carbon dioxide. Here metal is extracted. Zinc metal is extracted. So you just see this removal of oxygen takes place, right? Removal of oxygen takes place. So this process, smelting process, is a reduction process. Smelting is a what process? Reduction process. Right. Smelting is a process of reducing the metallic oxide to form metal. So smelting is a reduction process in which metallic oxides are reduced to metals. Right, this is called smelting process. Simply the impurities are removed by adding the flux, and then it removes as a slag. Right, so this is what the idea, my dear children. The smelting process is nothing but it's a reduction process. We reduce metallic oxide into metals. I hope the terminology used in the metallurgical process you learned thoroughly. I hope this video will be very helpful in the learning the terms involved in the metallurgical process. Thank you so much, my dear children. If you like this video, subscribe and click the bell button to get the notification instantly. Like this video, comment and share to your friends. Thank you.